Have you ever wondered how gliders and sailplanes fly without an engine? The answer lies in the basic principle of aerodynamic lift. As air flows over the wings of these aircraft, it generates lift, a force that opposes gravity and keeps the glider aloft. This might seem magical, but it's all about physics. Imagine the air as a fluid flowing around the aircraft. When the fluid hits the wing, it splits, part going over the top and part going underneath. Now, the shape of the wing, or its airfoil, is designed in such a way that the air on top has to travel a longer distance. This creates a difference in pressure between the top and bottom of the wing. The higher pressure below and lower pressure above generates lift, pushing the glider upward and countering the force of gravity. So, the secret to glider's flight is all about aerodynamics and lift. Now that we understand the basic principle, let's delve into the construction of these engineless wonders. Each component of a glider is meticulously designed to maximize performance and efficiency. First, let's talk about the wings. Notice how they are long and slender with a high aspect ratio. That's the length to width ratio. This shape is crucial to generating lift efficiently. The wings are the heart of the glider, the driving force that opposes gravity and keeps the aircraft soaring high in the sky. Next, we have the fuselage, the body of the glider. It's sleek and streamlined, cutting through the air with minimal resistance. You could say it's the embodiment of aerodynamic elegance. This design helps reduce drag, enabling the glider to maintain its speed and altitude for longer periods. Finally, we come to the tail section. It's not just there for looks. It serves a crucial role in controlling the glider's movement. The tail comprises horizontal and vertical stabilizers and control surfaces like elevators and rudders. Together, they control the glider's pitch, yaw, and roll, enabling the pilot to steer the craft skillfully through the air. But it's not just about the individual components. The real magic happens when they all work together. The wings generate lift, the fuselage reduces drag, and the tail controls movement. It's a symphony of aerodynamics, each part playing its role to perfection. The construction of a glider is a testament to human ingenuity, harnessing the power of natural forces to achieve flight without an engine. It's a delicate balance of science, engineering, and art, all working together to create an experience that's nothing short of exhilarating. So, from the wings to the tail, every part of a glider is designed for efficiency and performance. It's an incredible feat of engineering that allows us to soar through the sky, feeling the rush of the wind and the thrill of flight. Wondering how these engineless aircraft get off the ground in the first place? Let's delve into the common launch methods for gliders. First up is the tow launch. This method involves towing the glider into the air using a powered aircraft or a winch. Once the glider reaches the desired altitude, it's released from the tow line, allowing it to glide freely. Next up is the aero tow. In this case, the glider is equipped with a retractable hook that enables it to be towed by a powered aircraft. This technique offers a controlled and smooth ascent to the desired height. Lastly, we have the winch launch. This involves a winch on the ground rapidly reeling in a cable attached to the glider. The resulting tension propels the glider into the air, allowing it to catch the wind and begin its engineless journey. Whether towed by another aircraft or launched by a ground-based winch, getting a glider into the air is a fascinating process. Once in the air, gliders use a variety of soaring techniques to stay aloft. Let's take a closer look at these techniques. The first is thermal soaring. Here, pilots take advantage of rising columns of warm air, known as thermals. Just as a bird circles to gain height, glider pilots do the same within these thermals. The sun heats the earth heats the air above it, and this warmed air rises, creating the thermals. By circling within these invisible columns of rising air, gliders can gain substantial altitude, extending their flight times significantly. Next up, we have ridge soaring. This technique involves flying along the updrafts created when wind strikes against hills or mountains. As the wind hits the side of a hill, it's forced upwards, creating a consistent updraft. Gliders can ride this updraft much like a surfer rides a wave. By staying close to the ridgeline, pilots can traverse long distances without losing much altitude. Finally, there's wave soaring. This is a bit more complex and relies on waves of air generated by the wind encountering mountains or other significant obstacles. When a stable wind blows over a mountain range, it can create standing waves of air on the leeward side. These waves can extend to great heights, and with the right conditions, gliders can ride these waves to achieve remarkable altitudes, sometimes even reaching the edge of space. Each of these techniques requires a detailed understanding of meteorology and the ability to read subtle cues in the atmosphere and landscape. It's a game of strategy and skill as pilots navigate the invisible highways in the sky, using the energy of the atmosphere to power their flight. So, skilled pilots use these soaring techniques to transform the forces of nature into extended, exhilarating flights. Just like any other aircraft, gliders come in all shapes and sizes, each with its unique performance capabilities. When it comes to design and performance, the diversity in gliders is truly astounding. Some gliders are compact and agile, designed for performing breathtaking aerobatics in the sky. Others are built for endurance, boasting long, slender wings that enable them to ride the air currents for hours on end, covering vast distances. Modern sailplanes often incorporate advanced materials such as carbon fiber to enhance their performance and efficiency. This lightweight yet incredibly strong material allows for a sleek and streamlined design that reduces drag and maximizes lift. But the innovation doesn't stop at materials. High-tech design features are also commonplace in contemporary gliders. From advanced aerodynamic shapes to sophisticated control systems, these features help pilots to extract every ounce of performance from their aircraft. And what about performance? Well, let's just say that the capabilities of these engineless wonders might surprise you. Some high-performance gliders can achieve impressive glide ratios, capable of traveling several kilometers horizontally for every meter of altitude they lose. This means that from an altitude of just 1 kilometer, these gliders can traverse distances of up to 50 kilometers without a single beat of an engine. From aerobatics to long-distance flights, the world of gliders is as diverse as it is exciting. Flying a glider is not just about skill, but also about safety. Pilots seeking to master these engineless wonders undergo rigorous training, delving into topics such as aerodynamics, meteorology, and navigation. They learn to read the sky, interpreting the subtle cues that hint at hidden thermals or incoming weather fronts. They study the art of navigation, plotting courses over vast, unmarked terrains. But it's not all about the skies. Safety procedures are a critical part of their training as well. Gliders are equipped with safety equipment designed to protect the pilot in case of emergencies. Parachutes are a standard feature, providing a last line of defense should something go wrong mid-flight. Similarly, cockpit restraints are there to secure the pilot, ensuring they stay safely in place during the dynamic maneuvers that are often part of a glider's flight. So while gliding can be an exhilarating experience, safety is always a top priority. Gliding isn't just a hobby or sport, it's a community. A world where passion for the skies blends with camaraderie on the ground. The gliding community is a diverse collection of enthusiasts, hobbyists, and professional pilots, all united by their love for this unique form of flight. In every corner of the world, gliding clubs are more than just a place to fly, they're a home. These clubs are where friendships take flight, where knowledge is shared, and where the thrill of soaring is experienced. They're the heartbeat of the gliding community, organizing recreational flights and providing support and guidance to new members. Beyond the clubs, the gliding community is also marked by a range of exciting events and competitions. These gatherings are a testament to the skill, precision, and artistry involved in gliding. They highlight the best of the best, from awe-inspiring distance flights to nail-biting precision landings. These competitions attract pilots from all over the world, each with their unique approach and style, showcasing the diversity and dynamism within the gliding community. But more than the competition, these events are a celebration of shared passion. They're a chance for glider pilots to connect, learn from each other, and revel in the joy of flight. They embody the spirit of the gliding community, collaborative, supportive, and above all, passionate about the skies. From local clubs to international competitions, the gliding community is a vibrant and welcoming place for anyone with a passion for flight.